Let's do it this way. We got 0.096 moles of hydrogen, and the sodium hydroxide then is 0.14 times 0.800 moles per liter, and for that we get 0.112 moles of hydroxide. Now we've got more hydroxide than we have acid. So this gets eaten up, and then we're going to subtract 0.096 moles of the base because it gets neutralized by all that acid, and we end up with 0.016 moles of hydroxide. So we're going to put that into our chart. So for this right here, we said 0.112. The sum of the volumes are 0.26. The moles of excess, then we said, is now on the base side, it's 0.016 of the hydroxide. And we divide this by this, and we get 0.0615 moles per liter of the hydroxide. Now, before I do the pH for this, I want to show you something here. And this will simplify life for you tremendously when you find pHs. Now, we know that pOH is equal to the negative log of the concentration of hydroxide. Okay? Now, if I want to find the pH, we also know that pH is 14 minus the pOH. Right? If I plug in this for pOH, this gives me 14 minus a negative log of the concentration of hydroxide. So the quickest way to find pH is to take 14 and minus the negative is plus the log of the concentration of hydroxide. So what we're going to do in order to find the pH is we're going to take 14 plus the log of that number right there, and that turns out to be 12.79. Again, I don't look at sig figs for pHs, I look at 2 decimal places. So just leave it as 12.79. We'll do, now this is what we call section 4. Now we have more acid, or more base rather than you have acid. And you can see the huge jump in pH when you go from section 2 to section 4. It's tremendous. Okay, so let's go ahead and put our last set of numbers in there. So again, we got 0.096 of the H positive, and we've got 0.16 liters times 0.800 moles per liter, and that's going to give you 0.128 moles. I see I've done the wrong calculation here, so I'm going to have to do some quick calculator work when you want to get to that point. So let's put those numbers in. We've got 0.128 here. The total volume is 0.12 and 0.16, which is 0.28. And the moles of excess, then we subtract 0.96 and get 0.032 moles of hydroxide. Now I have to do some quick calculating work here because I screwed that calculation up. 0.032 divided by 0.28 is 0.114 moles per liter of hydroxide. And then I get 14 plus log of my answer I get 13.06. That is how you fill out a chart. You go through all the possibilities. By the time you're done doing one full chart, you become an expert. You're going to be doing 2 charts for your practice problems. But before we get to that, I'm going to show you something that'll help you understand maybe where you're doing what calculations and why. And that deals with the stages that we were talking about here. So, I want to come over here and I'm going to do a quick graph, approximate graph of what just happened there. So we start off with basically just barely above the origin there for 0.10 for the pH when we didn't have any milliliters of pH. And then at 20, it was just a hair. At 60, it was at approximately, the pH there was 0.5, so that's a quarter of the way up. So just increase there. At 0.08 is 0.8. It's still not quite there. It's just barely moving. At 0.10, which is halfway, I'm sorry, at, let's see, at 100 rather, the pH goes up to 1.14. Again, a slight change. At 120, however, it goes up to 7, which is right about there. At 140, it jumps to 12.79, which is right about there. And then 160, it starts to taper off. So the graph of this thing starts really low, and then jumps, and then does this. That is the titration curve. Now I'm not going to be asking you to do the titration curves, but I am going to show you the various stages on this and what they mean. So this right here is stage 1. Stage 1. And that is at stage 1. Actually, let's bring it over here. And just label this as stages. 1. So we have no base, which means that the pH is going to equal to the negative log of the concentration of the acid, whatever it is. Stage 2 is from here to just above stage 1 where it begins, and this is where the acid strong acid is greater than the base, and the pH then is going to be actually less than 7. Stage 3 is that point right there. We call that point the equivalence point. And that means that the concentration of the acid equals, actually let's just use moles because concentration sometimes it's kind of misleading. So moles of acid equals moles of base. We use H positive for acids. Moles of H positive equals moles of OH negative. And that means then that the pH equals 7. And then the 4th stage, which is anything above stage 3, we now have base is greater than acid, and that means the pH then will be greater than 7. there you have the analysis of titrations. So, practice problems. You have 2 sets of titrations right there. You can use your own sheet if you want, or you can use the sheet that I have sent you. Either way, have fun.